Well, hello and good evening. Welcome to another Monday night live Q&A session. We hope that everybody's well and taking care of each other. Joined tonight by my colleague from the technical helpline, Mark Barnes-Ryder. Good evening, Mark.
Evening, Sam.
And how are you this evening?
Yeah, very well, thank you.
Yeah, good. Anything exciting in the electrical world from your side?
Nothing that immediately springs to mind. We've got the usual questions, questions around certification. What sort of certificate do I need for inspecting an existing emergency lighting system? Those sorts of questions. Usual questions around earthing and bonding. Some nice questions around particular installations and size of cables and the method of installation, which makes it quite interesting.
We're always asked wide. It's always, I think it always amazes people on the helpline just how wide our industry is. And so one day you can be being asked about earthing on bonding or a two-way lighting circuit, and the next day it could be something about medical locations and supplementary bonding requirements. So yeah, it's a very wide industry. Okay, so without any further ado, we'll put up our question of the week that was posted out onto the different forums earlier today. So that was a question that came about for somebody who was looking to size conductors, and so wanted to know the current, the full load current of a 12 kilowatt 3-phase 400 volt motor that had a full load power factor of 0.9. Because of the inductance of the load, we have to consider power factor, and we gave people four alternatives. So we made it multiple choice. A few people did come back quite rightly and say that our question hadn't actually considered motor efficiency, which is true. So we've done it based on as if the motor was 100% efficient, which we're fully aware is actually not achievable due to the losses associated with the electric motor. Those people that said they would need to know that, fair comment, but yeah, we were hoping that you'd do it based on the information provided in the question. So to put people out of their misery, the formula that we were going to be using would have been the power of the motor divided by the phase voltage, so √3 times the line voltage, and then multiplied by the power factor. So in our instance it was a 12 kilowatt motor, which means that it was 12,000 watts. And then we were given all of the other data, so we knew that our line voltage was 400 volts, power factor was 0.9, so it was a case of crunching those numbers through that calculation to give us that value of 19.25 amps. But yeah, normally you would also factor in the motor efficiency. Totally agree with the people that did make those comments on social media.
I mean, there could be other factors as well there, Sam, couldn't there? We did it as a straightforward calculation, but not taking account of sort of installation methods or even the type of motor, because if it was the type of motor that was stopping and starting, as in a compressor in a motor vehicle workshop, then you'd have to add other factors to help calculating the load as well. So, or add a rule of thumb factor, should we say, for the added sort of inrush current really on startup. But this was done as purely as a desktop calculation, wasn't it?
Yeah, pure, and it was really just to emphasise. I think that the person who asked the question originally forgot about the √3 factor, and so obviously resulted in a much different current. So that was really one of the things that we wanted to bring people out, that just be aware when we're working with three-phase, that we have to consider that root 3 factor when we're looking at the individual phase currents. Okay, we'll take a few more questions that we've had sent in through. So first one, should a main protective bonding conductor be connected to a building's lightning protection system? So what are your thoughts on that, Mark?
Yeah, well, I mean, absolutely. If you read the reg, it does say shall be connected in accordance with BS, 62305, but they can be very complex and due to various design criteria. So we'd recommend that the exact position of the bonding conductor is actually discussed and agreed with the lightning protection designer, as well as normally the connections are made to the down conductor, but the protection system closest to the MET by the most direct route. And I can say from experience that BS 62305 will recommend a minimum size for the bonding conductor, and it's considerably larger than the large size of bonding conductors in BS, our wiring regs. So we recommend that you always go to the designer on that.
Yeah, because it's considered as an extraneous conductive part, isn't it? So if there were to be a lightning strike, and so now our lightning conductors are taking that huge voltage, thousands of volts, there's the potential for flashover into the installation, isn't there? So hence the need for it to be bonded, but also to be bonded with large sizes, due to it's introducing a much greater potential than we normally consider when we think about extraneous conductive parts introducing a potential. So yeah, big sizes.
Yeah, absolutely. I mean, even there's the potential for that lightning strike to distort sort of other conductive or metallic parts sort of fixed to the building as well, such as staircases and balustrades and things like that. So I have actually seen balustrades on first floor sort of balconies bonded to the down conductor, but that would have all been agreed as worked out as part of the design, the overall design, and the risk assessment taken into account.
Yeah, so I think it's fair to say yes, they need bonding, but it's a specialist area, isn't it? You need to seek that specialist advice from the designer of the lightning protection system.
Absolutely, yeah.
Okay, another one, a common one that we get asked from time to time: can flexible cables be used for the fixed wiring in a domestic installation?
They can. Regulation 521.9.1 says that it can, but it will specify, I think it's a medium duty or a heavy duty cable should be used, unless you can use a slightly less heavy duty, but you'd have to provide it with additional mechanical protection and install it in such a fashion to sort of minimise the risk of those cables becoming damaged once they're during installation, but once they're installed as well and put into normal service. I mean, you need to consider the suitability of the environment. I think if any installations that were designed to the 16th, it wouldn't have been allowed, but the 18th has allowed them, and I think that follows the product sort of improvements over the years to cables that makes them, your BS. I've forgotten the BS number now, the cable, sorry folks, but the heavy duty cables, the sort you see for cranes and power tools that have got a really high resistance against abrasion, but they've got a high current carrying capacity, so why not? They'd be quite more than adequate in some installations, especially where you've got a lot of movement. And don't forget, where you've got machines in factories and things like that are perhaps moved on a regular basis. the flexible cables will account for any sort of they'll smooth out any vibrations from the machine to so reduce the risk of the if they were solid core cables perhaps coming loose due to vibration.
So it's
absolutely.
It's really based on suitability for the environment. Has it got good enough mechanical protection, or like you say, you might have to add some additional. But I think a lot of the confusion is because, like you say, if we go back, it sounds like a long time ago now, but it doesn't feel that long, to sort of 1990s and before. It was precluded. You weren't allowed to use them. That it was specifically stated. But as you say, things change, and there's a recognition, I think. Typically, if we say, for example, domestic, there's lots of parts of a domestic installation which aren't a harsh environment, and so they could be considered. But yeah, you've always got to, like with everything, it's got to be suitable for the environment in which we install it in, or the way that we install it makes it suitable. So yeah, there's nothing that precludes it. And as you say, in that section in 521.9, it does actually talk about certain instances where they're recommended because of their, like you say, because you're going to get less stress on the cable or its connections because you're taking advantage of the flexibility of it.
And certainly, if you look in other sections, in section 7, were for sort of transportable vehicles or caravans, that sort of thing, they recommend flexible conductors, don't they? Yeah. Where there's a lot of vibration, a lot of movement. So again, there are installations that lend itself really well to flexible cables. Yeah. And the technology such these days is that the cables meet all of the performance requirements. So yes, it's as you say, suitable for the environment.
Yeah. Another one that we had, which was what are the height requirements for socket outlets installed to supply caravan pitches on camping and caravan sites? So are there any heights in 7671?
There are. There's they recommend a minimum height of between 5 meters and 1.5 meters, unless it's in an area sort of that could be flooded. So if you're in a sort of floodplain area, then you can actually increase the height to the lowest part of the socket, if you like. So that 0.5 meter to 1.5 meter is to the lowest part of the socket outlet. So that can be increased above 1.5 meters as necessary, subject to risk assessment of the environmental conditions. So absolutely.
Yeah, I think
regulation. Yeah,
I think one of the things they talk about is if you're in a high flood risk area, isn't it, that you can actually raise it above that. If you're in a floodplain that regularly or quite likely to get surface water pooling, then you may need to go higher. But yeah, yes. 0.5 to 1.5 as a minimum. And another very common question that we get to the helpline, because again, this is one of those ones where things have slightly changed in recent times. So when doing a domestic installation rewire, is it a requirement to fit a fire alarm system? So let's say we go to a domestic, there's no fire alarm system there at the moment at all. We're being employed to do a complete rewire. Do we have to provide a fire alarm system as part of the rewire?
It's not a specific requirement. I mean, there isn't a reg that says you should provide a fire alarm system. BS 7671 is all wiring systems generally, but it recognises that BS 7671 will often need to be supplemented by other British standards. Okay, so it states that the regulations are intended to be applied to electrical installations generally, but as we just said, they may want to be subsidised by other British or harmonised standards. So there is a separate British standard, as we all know, 5839 Part 6. The latest issue is 2019. And it makes a recommendation in there where electrical work such as a rewire is undertaken. Then it recommends a grade D category LD2. Now that could be a grade D1 or a grade D2. It's designer's choice. Or another thing may be that if there's major alterations or change of use, so let's stick with major alterations that impact the rest of the property. If you've got a large extension, if those alterations impact an existing or part of an existing system that's there, then they may require that the whole system as a whole is upgraded to a D1 or D2. And don't forget, they're not identical. The regulations, the building regulations, they're not identical throughout the UK. They are through the UK, but not all through the British Isles. So you've got Wales, you've got Scottish building regs as well. So you might need to look at those Scottish building and the Welsh building regulations for any bespoke, if you like, to meet their building regs.
But I think there was a change, wasn't they? So in BS 5839, it used to say it was recommended on a rewire, but in the last update, which was 2019 of 5839, it actually changed to shall be. So I know we're predominantly concerned with 7671, which doesn't specify, although in our fundamental principles it does say that the requirements of the regulations are supplemented by other standards, and it actually mentions the fire detection and alarm standard 5839, and as I say, that the last change to 5839 part 6, it changed from, it was a recommendation when doing a rewire to a shall. So the regulation actually became, where electrical work such as a rewire is undertaken, a grade D category LD2 system should be installed. So it became more of a requirement in the last update in 5839. Let's have a look. So starting to see some questions come into the room now. So kitchen down spotlights need to be fire rated. So again, very common question that we get to the helpline about fire rating of downlighters, and it really falls into two camps. 7671 requires you to ensure that you're not putting heat generating items close to combustible material or covering them in combustible material. So 7671 doesn't talk about fire rating requirements, and generally if you comply with manufacturer's instructions with regards installation, so you distance them from joists and combustible material and you don't cover them unless they're rated for such in thermal insulation, then you'll normally comply, and you fit the right rated lamp in the fitting, then you'll comply with the requirements for 7671. Generally the requirement for fire rating is driven by building regulations, where we've not got a building of robust construction. So we need to talk about thickness of floors and ceilings, thickness of joists, distancing of joists, and that will determine whether fire rating is required. So in a typical domestic, it really does depend on robust construction. Generally a normal domestic house built in the last 20 years will be of considered robust construction, but I'd perhaps point you in the direction of Best Practice Guide 5, which you can freely download from Electrical Safety First. Has got some very good information. It's got a clear definition of what robust construction is in terms of thickness of floors, thickness of ceilings, thickness of joists, distance between joist centres, and that will help you, but really get some guidance from building inspectors if we're talking about new builds, because it will be down to the construction of the building that really drives whether it wants fire rating or not. Anything you'd add to that, Mark? It's a common question, isn't it, that we get?
It is, yeah. No, I mean, Best Practice Guide 5 springs to mind. There's a couple of appendices in there, and there's a couple of tables as well that give you table 1, I think it is, an Appendix C. Appendix C talks about the robustness of construction, and there's a handy little table in there that basically gives guidance on where you don't have to fit fire-rated downlighters in existing properties. But I think that's pretty much it. And as you said, it is a building reg for new builds, document B. But Best Practice Guide 5 provides an awful lot of information actually compared to some of our other guides. So make sure you download that, because as Sam says, it is a free download, and that will point you in the right direction.
Okay. We've got one. What certificate should be used on an industrial building management system when MCBs are located within the building management system? The wiring should still be compliant with 7671 unless the building management system is a standalone product complying with a defined product standard. I guess if the MCBs are controlling control equipment to meet the requirements of the BMS system, then you still need, if they're going out to actuators, valves, fans, etc., then you're still going to need to consider those as final circuits and document them as such on an installation certificate. And any other thoughts that you think on that one, Mark? So that
yeah. I mean, you could list it as a lay it out the same as you would lay out fuse board final circuits on your certificate. So a conventional commercial certificate, I think it's a DCN 18, I think, off the top of my head, but you would make it clear on that certificate that that's what you were doing. So you could even attach a block diagram showing the whole of the installation. And if when you got to that panel to carry out the required test that you knew they didn't meet the requirements for fault protection, then you'd need to go back to the designer of that control panel. Sometimes these panels are kind of built not to any particular standard, and that's often where you find the issues, in my experience. But where they're built to a product standard, they should comply, and you shouldn't have any issues. But there's no hard and fast rule that says you can't add it to your installation cert. You just need to make it clear on the certificate that it is, a BMS panel, and then you could list the individual circuits.
Yeah, I think one of the other engineers that's in the same chat room has said you can make your own, but standard forms can be used, which is quite right. So quite often instrumentation work like this, they tend to work from loop diagrams and loop sheets. So but there's nothing wrong with that, providing they still provide those minimum requirements to meet 7671, so that you're recording the right information, the tests to confirm that the installation's safe for continued use. So you're looking at things like insulation resistance, polarity, overcurrent protection, fault protection. So yeah, there's nothing to stop you using prescribed forms. Perhaps the building management system supplier have got other alternative forms to those, the templates that are in Appendix 6, and there's nothing to stop you using those, providing they still provide the same information, or as a minimum the same information. Another question that's come in. Recent EICR found a short between neutral and earth on a lighting circuit. What code would you suggest, as I realise it doesn't comply but not sure it's dangerous? Well, there are a couple of things that spring to mind. It would be a little bit dependent on the earthing system, because if it was TNCS or TNS, we would expect the neutral to be at earth potential. But strictly speaking, if there's a short, then we've gone down the route of we've not got insulation resistance of greater than 1 meg. So I think I'd be looking at a C2, because we've now got the situation where all of our everything that's connected to earth, including all of our circuit protective conductors and our exposed conductive parts, could now carry that live potential associated with the neutral, and be a path for currents. So I think I'd be looking at a C2 recommendation on the basis that we've got insulation resistance below 1 meg. Someone else has suggested perhaps an FI, but I mean that's going to result in the same overall outcome, unsatisfactory. But if you know what the issue is, I'm not really sure it warrants an FI, unless you wanted to find out what was causing it, obviously, to put it right. But either way, I think you'd be looking at an unsatisfactory outcome. Okay, we've still got the question, I think, about the fire rate. So with a 1 hour fire rated ceiling, I'm using a commercial non-fire rated LED fitting with a fire hood. Should driver and junction be kept inside the fire hood, or can it be above the fire rated ceiling? So there's a few different questions in there, really. I think if we're talking about premature collapse and using the fire rated ceiling to provide that, but I'd get some information from the fitting manufacturer about the driver and the junction, whether they'll be suitable to be fitted inside the fire hood, because obviously you may be increasing their heat that they're going to be associated to or be introduced to by the fitting. So I'd get some strong guidance from the manufacturer of the product. So I'm just going to read it again. With a 1 hour fire rated ceiling, I'm using a commercial non-fire rated LED fitting with a fire hood. Should driver and junction be kept inside the fire hood? Yeah, I think I would get some guidance from the manufacturer as to whether they're suitable to be installed that way, because obviously you're going to increase the heat that they're subjected to. The fire hood is really to ensure that if there were any heat or spark or fire generated by that fitting, it's not going to be expanded out throughout the rest of the building. So yeah, I think again you want to make sure that if you are required to have that fire rating of the ceiling, that your installation method maintains that. So you may need to seal or install properly, but again get some firm information from the manufacturer.
Could we go, Sam? Can we go back to the fire alarm question at the beginning, because you've said that there's a shall in BS 5839 part 6 to install smoke alarm or fire detection system. But what about if the client turns around and says, well, actually let's take the rewire, and the client turns around and says, well, actually we can't afford that, or we don't want those put in place? Where does the electrician, the installer, stand then? Because presumably would it have an effect on whether they go ahead with the rewire or not?
Well, strictly speaking, it's two parts, isn't it? So 7671 doesn't require, although as we said in our fundamental principles right back in chapter 1, then BS 7671 does confirm that the regulations may need to be supplemented by the requirements or recommendations of other British or harmonised standards. So that really says that if it's relevant, then you've got to comply with 5839 part 6. So as we said, that was one of the subtle changes in 5839 part 6 when it went from the previous version, which I think was 2016 up to 2019, it changed, and it said where electrical work such as a rewire is undertaken, then a grade D in brackets D1 or D2 category LD2 system should be installed, and that was a change in 5839. Prior to that, it had been a recommendation. So now we'd be, if we didn't do it, we'd be knowingly not complying with BS 5839 Part 6. Now that's not it's not a legal requirement, it's a recommendation, the whole British standard. But I think our advice would be we should be complying with that, because if anything were to happen, you've really got no justification for saying, well, I chose not to, and I think it would be very difficult, even if your customer says, I adamantly don't want to, it's not been quoted for, whatever. You're the designer, you've got to be the person taking responsibility. So yeah, I think it's a conversation to have very early on, if you're going into domestic installations to do a rewire where you notice that there aren't any that there's no fire alarm system at the moment. So I think our advice would be we should be complying with 5839 Part 6.
Thanks for that.
Okay, we've got a colleague asking us a question that we might come to the end, which thanks Jake, I appreciate it. What the question is, what I would like to know is, what are Luton's chances of staying up? I think that's a terrible question to ask after only 2 games, but good to see you, Jake. Okay, with current PRS regs and a rewire is recommended after a test, what is the duty of care on the testing contractor if he or she fails an installation? So with the current PRS regs and a rewire is recommended after a test, what is the duty of care on the testing contractor if he or she fails an installation? I'm not really sure where that one's going, but what I would say is, obviously, if you're employed to do the inspection and test process, you can only make your recommendations. So, for example, if due for it perhaps to poor insulation resistance values or other reasons, you are recommending a rewire, but the person who's asked you to do the inspection and test is flatly refusing to follow your recommendations, then that's as far as you've gone. You've documented what you believe that should happen, i.e. your recommendations. We've got no authority to enforce those recommendations, but so long as you've documented them, that's as far as you can go. Difficult, I know, but that would cover your duty of care. You've not got the responsibility of making it right. I think general guidance is, if we see C1s, so if we see instances where there is present danger, then we should do everything reasonably practical to remove the hazard or minimise the danger to the users of the installation, and again bring it up to the responsible person who's asked you to do the inspection and test process. But ultimately, if the owners refuse to put things right, so long as you've documented them and you've made it clear to them what the hazards are and what the potential risk is, that's as far as you can go. It won't then be your fault if the responsible person, i.e. the landlord, doesn't take your recommendations any further or flatly refuses to follow them. Again, another difficult one, but it's not your responsibility, it's the landlord's responsibility when it comes to PRS. Would you add anything to that, Mark?
Yeah, no, only the fact that each electrician has a duty of care to make safe, not only to remove the danger from the users of the installation, but themselves as well under the electricity at work regs, which actually falls under the Health and Safety at Work Act. So it's not, it's to prevent yourself from that danger as well, from coming into contact. And as you rightly say, Sam, with the PRS, the duty is on the landlord or whoever owns that property, and they'll have the local authority to evidence that they're doing everything they can to maintain that property.
Yeah. Okay, we've got another one of the engineers has sort of qualified some of the stuff we've said. Mentions that in safety services section of 7671, it does state that fire detection shall be installed in accordance with 5839. So that kind of backs up what we said about making it a requirement now to under rewires. Another one, in a 3-phase domestic installation, what minimum distance between accessories or equipment that are on different phases? There's no specified requirement, and in fact gone are the days where we used to put stickers on everything if we had different phase voltages in the same enclosure, or even at the same accessory. There's only a requirement to fit those voltage warning labels when we're above 230 volts to earth, and as all phases should be typically 230 volts to earth, there's no requirement to fit voltage warning labels. So yeah, there's no specified distances. So yeah, and not a requirement. Obviously you need the right protection on each phase, and in those instances where you've got an enclosure or even an accessory where there are more than one phase, and so isolation of that enclosure or accessory requires you to isolate from 2 different points or more, then that needs to be identified with labelling. So there is a standard label which talks about multiple supplies. So effectively, at a convenient point with inside the enclosure, for example, you could tell people that this enclosure contains circuits fed from phase 2 and phase 3, and therefore total isolation would require isolation of a protective device or isolator for phase 2 and phase 3. So, but there's nothing about distances, not that I'm aware of. Mark, anything you can think of?
No, I mean, you're quite right, Sam. I mean, the regulation that comes into play is 514.10.1, and generally, voltages produced in the UK are, as you say, 230 volts line to earth, unless it's some form of special installation, in which case, there may be some bespoke labelling required. But the point you make about isolation, there is a general label out there that says more than one point of isolation that could be used, but there's no distances involved, not in BS 7671. As far as we're aware, there may be in distances in other British standards, but not in BS 7671.
But I think again that's one of those things that's changed over the years, hasn't it? That we used to be very nervous about having different circuits, different items of equipment on different phases in the same locality, and we used to get perhaps a little bit carried away with warning labels, and then somebody realised, but wait a minute, in every 3-phase board we've got 3 different phases all in the one enclosure, and it seems to be safe enough. So I think we kind of over the years we've taken a step back, and there was a subtle change in the requirement for that voltage warning label, in that it changed from anything above 230 volts to anything above 230 to earth, because in the previous version people saw the 400 volts and said, oh, it needs a warning label because it was 400 volts between the line conductors, but it's still only 230 volts to earth. If you are spurring from a socket to install a switched fuse spur for outside garden lights, On the minor works, would you put the 32 amp 60898 as the overcurrent protective device, or the 5 amp 1362? Okay, so this is where we're coming off a ring, I guess. We're going into a fused spur, and then we're going out from the fused spur to the garden light. So we've got the two protective devices. We've got the fuse in the fused spur, but we've also got, in this case, the breaker, the 32 amp 60898 at the board, protecting the ring. Our suggestion would be to document it almost in two halves. So you've got the feed to the spur, and the feed to the spur is being protected by the 32 amp 60898. So if, for example, call that circuit 9, and then circuit 9A is from the load side of the fused spur, so then that would use the 5 amp 1362 fuse as its protective device. Strictly speaking, it's one circuit because it left the board once, but because you want to document that you actually have got two parts, you may quite commonly have a reduction in conductor size, and hence have the second overcurrent protective device. But yeah, our suggestion would be to document it in two halves. Would you agree with that, Mark?
Yeah, I mean, it's one of those where there's no right or no wrong sort of answer for that, because you could even document your overcurrent protective device just for the alteration on a minor work certificate, and then you would state that on the minor work certificate, you know, what does this minor work certificate cover? So you could go either way on that, and equally would be fine, as long as you can clearly show that your overcurrent protective device adequately protects that cable and affords it the fault protection that's required. So but certainly would be a good way to split it in two halves, and you just need to describe that on your certification. You know, in all of this, information is key. The more information you can put down on your paperwork, the less you're likely to be challenged on it, and everybody knows what's going on. That's what we generally say.
Yep. I've got one there. It says, for a commercial unit, need condition report, and old style three-phase consumer unit, it's still acceptable. So for a commercial unit, need condition report, and an old style three-phase consumer unit, it's still acceptable. So perhaps need a little bit more information. Yeah, you definitely need condition reports on commercial units as well. So it's not just PRS, but it's all installations that need to be considered about confirmation of safety for continued use. So yeah, not really sure where you're coming from with the old style three-phase consumer unit, so perhaps a little bit more info there. And so we'll finish tonight on another common one that we get, especially this time of year. So at what depth should a cable be buried in a domestic garden for an outdoor lighting installation? So have we got any depths in 7671?
I mean, it suggests that it doesn't give you a specific depth in the reg 522.8.10, but it says it should be buried sufficient to avoid any reasonably foreseeable disturbance of the ground. I mean, we recommend a depth of sort of 0.5 of a metre, sufficient to avoid damage by general gardening activities and things like that. But again, it's looking at the environmental conditions. You know, if you were running underground cables across a caravan park, I think the recommendation in section 7 is 600 mil, 0.6 of a metre. You know, if you're running cables underneath a carriageway or which is traversed by vehicular traffic, then I think the minimum depth is possibly 450. It might even be 600 actually. But the point I'm making is that you have to assess the environmental conditions and assess the likelihood of whether they're going to be damaged, what sort of digging's going to occur. If it's If it's going across a ploughed field, then again, you know, it might need to be buried deeper. I mean, it's worth looking at the table for correction factors for buried cables in the regs, because to achieve a correction factor of sort of 1 or unity, as we often say, the table shows a depth of 700 mil, so 0.7 of a metre. But what we're trying to get across is that for general digging purposes, 0.5 metre is what we recommend as a minimum.
Yeah, absolutely. So there's no dimension actually quoted in 7671. It just says at a sufficient depth to avoid being damaged by any reasonably foreseeable disturbance of the ground. So like you say, where is it? If it's going under a path, then we would expect that not to be disturbed at all. You know, if it's a concrete path. If it's a flower border, then yes. If it's a vegetable patch, yes. So again, you need to consider. But they talk about as a good engineering estimate, 0.5 metre, and supplement that with some warning tape, 150 mil above. So hopefully, if anybody were to dig down, they'd hit the warning tape first, and also to provide a map, a drawing with any certificate, so that the next person who comes along has got some idea of the route that you've run the cable, just in case they want to avoid any sort of material construction that might go on in that area as well. We've had a couple. I know we're weighing, but we'll try and do these last two because they're both quite relevant. So our fire alarm one has generated an interesting one. So hi, you know, I think these are one of the ones that you kind of think, well, just started a domestic partial rewire today, and there is battery smoke alarms installed top and bottom landing. Customer did not want hardwired smoke alarms as I recommended. Can I note on the certificate, or are you saying I have to install them, say top landing and down landing and heat for the kitchen? Okay, so I think one of the things that would help there is you've actually said it's a partial rewire, which perhaps gives you a little bit more leeway than the requirement in 5839, which talks about a rewire. Without full detail, I would certainly say our recommendation would be that it's a strong recommendation that the required fire alarm and detection system be installed. So that would be a mains operated battery backed, and LD2 coverage would include a heat detector in the kitchen and smoke detectors on the communal escape route, so as you've got at the moment, top and bottom. So yeah, I think you've got a little bit of leeway if it isn't a full rewire, but yeah, I think you've got to document what your recommendations are, and also document that the recommendations in your instance were declined, just so that you've got coverage in the future. But yeah, I think it would be very different if it were a rewire, which is what is the terminology used in 5839 part 6. And then the last one, what qualifications do I need to complete a fuse board in my own home? You have to remember who we are that you're asking that question, and our answer would always be that you use a competent registered contractor to do that. You know, we're helpful people, but we would always insist that you should be employing skilled electrical people to do that type of work, because of the potential hazards and dangers involved. So we would always recommend that you employ a competent registered contractor to do such work. Anything that you'd add to that, Mark?
No, I think you've summed it up very well there, Sam. Actually, that would always be our recommendation. It's you know, horses for courses with some of the trades, particularly where it carries a high risk of danger if it's not installed correctly. You know, if you're dealing with water, then that doesn't perhaps carry quite the same level of risk. But certainly with, electricity or gas, then we would always recommend a competent electrician, competent person with relevant skills and training that can carry out that work.
Okay. All right. Well, thanks very much to everybody who posted questions. Once again, if we haven't got round to your question, I apologise, but we do trawl through them at the end of the night, and any that we pick up we'll bring forward into the next session. We've got a holiday next week on Monday, and then the Monday after's a bank holiday, so we'll be taking a break on the Monday nights now for the next couple of weeks due to that holiday and bank holiday, and we'll be back with you in September. We should also be announcing in the next couple of weeks the diary program for the wire sessions in September, that you'll be able to sign up to. I know we've got ones that are coming up on fire engineering issues, and also a Wednesday Q&A, so we can actually bring some of the questions that get regularly asked into fruition. So please keep an eye open on social media for that diary for September, which is going to be published very soon. Okay, so once again, thanks very much. Apologies if we've not answered your question. Thanks to all those that have asked questions and also helped each other out. All the good engineering comments in the chat room. It's always good to see. Any last thoughts or words from you, Mark?
No, just stay safe and make sure you comply with the requirements of 7671. And have a good evening, and we'll see you in a couple of weeks. Okay, see you again, gentlemen. Yeah, as Mark says, take care of each other.